Most cars cross 100,000 kilometers feeling solid. Then, the failures begin. Not randomly, but in a sequence that follows engineering logic, usage patterns, and the simple reality that every part has a lifespan. What breaks, when it breaks, and why it breaks isn't a mystery. It's a blueprint written into the car from day one. Understanding these failures means knowing what's coming, what causes it, and what it costs to ignore. Suspension components. Suspension fails first because it works hardest. Every pothole transfers force through bushings. Every turn loads the control arms. Every braking event compresses the shocks. Rubber bushings lose elasticity. Shock absorber seals leak fluid. Ball joints develop play. Spring seats corrode and crack. The failure happens in millimeters, too small to notice daily, too large to ignore after months. By the time you hear clunking or feel looseness in the steering, 3 or 4 parts need replacement together. The cost multiplies because suspension works as a system. Replacing one worn part while leaving the others means the new part wears faster, loaded unevenly by the old. You fix one corner. 3 months later, the other side fails. It never ends. Cooling system. Cooling systems are built with planned obsolescence. Plastic radiator end tanks expand and contract with heat thousands of times. Eventually, they crack. Water pump impellers corrode or lose blades. Rubber hoses harden and split. Thermostats stick open or closed. The danger isn't the failure itself, it's the timing. A radiator doesn't leak in your driveway. It leaks on the highway at speed, when the system is under full pressure and maximum heat. The engine overheats in minutes. Coolant floods out. If you don't stop immediately, the cylinder head warps, the head gasket blows. Or worse, coolant mixes with oil and destroys the bearings. A $50 hose becomes a $5,000 engine repair because the failure happened at the worst possible moment. And you sit there on the shoulder, watching steam pour out, knowing this could have been prevented. Electrical systems. Electrical problems grow in complexity after 100,000 kilometers. Mass airflow sensors drift out of calibration. Oxygen sensors lose sensitivity. Throttle position sensors send erratic signals. ABS wheel speed sensors corrode. Alternators lose voltage regulation. Engine control modules develop cold solder joints. The frustration isn't the failure, it's the diagnosis. A sensor can work perfectly for 10 minutes, fail for 30 seconds, then work again. The code clears. The problem disappears. Then it returns next week. You replace the sensor. The problem continues because it was a wiring issue, not the sensor. You replace the wiring. The problem was actually a failing control module the whole time. Diagnosis time costs more than parts, and the problem hides until the technician gets lucky or replaces everything in the circuit. You leave the shop lighter by $800, hoping this time it's finally fixed. Transmission failures. Transmissions don't fail suddenly at 100,000 kilometers. They've been failing slowly since 50,000. Automatic transmission clutch packs wear microscopically with every shift. Torque converter lockup mechanisms lose their bite. Valve body solenoids stick. CVT belts stretch. Dual clutch transmissions overheat in traffic. Manual transmission synchros grind down. The fluid breaks down, loses viscosity, and stops protecting metal-to-metal contact. What you feel is delayed engagement, harsh shifts, or slipping under load. What's actually happening is internal tolerances opening up beyond spec. By the time the symptoms are obvious, the damage is done. A transmission rebuild costs $3,000 to $5,000. A replacement costs more. And both options deliver a transmission that will never feel as smooth as it did when new, because the rest of the drivetrain has aged around it. You drive away from the shop knowing you just paid half the car's value to fix one component. And you wonder how long until the next failure. Fuel delivery. Fuel systems fail from contamination and age. Fuel pumps sit submerged in gasoline, cooled by the fuel itself. As they age, internal brushes wear, armatures lose magnetism, and output pressure drops. The engine runs lean. Power fades. Fuel injectors accumulate varnish from poor quality fuel or extended idle time. Spray patterns degrade. Some cylinders run rich, others lean. The check engine light appears. Fuel filters clog if never changed, and most are never changed. The restricted flow forces the pump to work harder, which accelerates its failure. Then there's the fuel pressure regulator, the fuel rail, and the evaporative emissions system. Each component has seals, diaphragms, or valves that deteriorate. A failing fuel system doesn't just reduce performance, it causes misfires, which damage catalytic converters, which cost $1,500 to replace. One ignored problem creates 3 new ones, and suddenly you're chasing failures instead of preventing them. Exhaust degradation. Exhaust systems rot from the inside out. Combustion produces water vapor. That vapor condenses inside the exhaust during short trips where the system never fully heats. The moisture sits. Steel rusts. Stainless corrodes more slowly, but still fails. Catalytic converters have a chemical lifespan. The precious metals inside, platinum, palladium, rhodium, lose their catalytic efficiency. Oxygen sensors fail from heat cycling and contamination. Exhaust manifolds crack from thermal expansion and contraction. Flex pipes tear. Mufflers rust through. The failure is invisible, until it isn't. A cracked manifold ticks loudly but still functions. A clogged catalytic converter chokes power and ruins fuel economy. A rusted-through muffler sounds like a race car but fails emissions testing. Repair costs vary wildly, depending on whether the failed part is welded in, bolted on, or requires dropping the entire exhaust system. You get the quote and realize the repair costs more than the car is worth on the private market. Engine seals. Every engine has 30 to 50 seals keeping oil inside. Valve cover gaskets compress under heat and lose their shape. Camshaft seals harden. Crankshaft seals dry out. Oil pan gaskets weep. Timing cover gaskets leak. Rear main seals seep onto the clutch or flex plate. At first, it's a few drops on the driveway. Then it's a stain. Then it's low oil between changes. The leak itself isn't catastrophic, but running low on oil is. Bearings score. Piston rings wear faster. Variable valve timing actuators starve for pressure. The engine runs rough, burns oil, and loses compression. The repair isn't expensive because the gasket costs $5. It's expensive because the gasket is buried under the intake manifold, or the timing cover, or the transmission. Labor runs 8 to 12 hours. The part is cheap. Access is not. And you sit there thinking about how a $5 piece of rubber just cost you $1,500 to replace. Brake system. Brakes wear in layers. Pads wear first, obviously, but rotors wear too, grooved, warped, or thinned below minimum spec. Calipers seize because the slide pins corrode or the piston seals leak. Brake lines rust from road salt. Flexible hoses crack from age and ozone exposure. The master cylinder develops internal leaks that don't drip externally, but send fluid backward into the booster. The brake pedal feels spongy. Stopping distances increase. ABS activates randomly because a wheel speed sensor is corroded. Most owners replace pads and rotors and assume the job is done, but if the caliper is sticking, the new pads wear out in 15,000 kilometers instead of 50. If the brake fluid hasn't been flushed in 10 years, moisture boils during hard braking, and the pedal goes to the floor. The entire system ages together, and partial repairs don't restore full function. You fix one part, another fails. You're always one step behind. Climate control. Heating and air conditioning systems fail predictably. Compressor clutches wear out. Evaporators leak refrigerant. Blower motors develop bad bearings and scream. Heater cores clog or crack and dump coolant into the cabin. blend door actuators strip their gears and stick on one temperature setting. Cabin air filters clog and restrict airflow. Refrigerant leaks slowly from O-rings and hose connections. The system keeps working, but poorly. The AC blows warm. The heat barely works. The defroster takes 10 minutes to clear the windshield. Diagnosis is expensive because the entire system is hidden, behind the dashboard, under the hood, inside the firewall. Finding a refrigerant leak requires UV dye, evacuation, and recharge. Replacing a heater core requires removing the entire dashboard. Labor costs exceed part costs by 3 to 1. You're paying someone to disassemble half the car just to reach a part the size of your hand. Interior materials. Interior degradation doesn't stop the car, but it kills resale value. Leather seat bolsters crack from entry and exit wear. Vinyl dashboards fade and crack from UV exposure. Door panel fabric sags. Headliners detach. Power seat motors burn out. Window switches fail. Cup holders break. Trim pieces rattle. Climate control knobs wear smooth. The failures are cosmetic but cumulative. A buyer walks up, sees a cracked dashboard and torn seats, and assumes the engine is equally worn. The car might be mechanically perfect, but it looks tired. The seller drops the price $2,000 because the interior looks like it has 200,000 kilometers, even if the drivetrain only has 100. Perception shapes value more than condition, and you realize too late that a few $100s spent on interior care could have saved you thousands at resale. Ownership context. At 100,000 kilometers, most cars change hands. The first owner trades it in. The second owner buys it used. Service history disappears. Maintenance gets deferred. The new owner doesn't know the car was driven hard or idled for hours daily, or never had its transmission fluid changed. They inherit someone else's decisions and someone else's neglect. When failures appear, they blame the brand. But the brand didn't cause the failure. Deferred maintenance did. Skipped oil changes. Ignored warning lights. Cheap parts installed by the previous owner. The car isn't unreliable. The car is a product of its history, and that history is now invisible. You buy a used car at 100,000 kilometers thinking you got a deal. 6 months later, you've spent $3,000 fixing things that should have been maintained years ago, and you wonder if you should have just bought new. Every failure after 100,000 kilometers is predictable. Parts have service lives. Systems degrade on schedules. Maintenance matters more than brand. The car doesn't become unreliable. It becomes honest about what it is and how it was treated. And if you understand that, you stop being surprised and start being prepared.